Might be
Really?
my pointer.
Oh, yeah? What?
Yeah.
I'll play by ear.
Oh, yeah.
Something else wrong too. Something else.
A better thing?
On like the same level.
In the land of unicorn ranches and lollipop farms, you're like a real farmer. So I expect good things will happen.
Yeah.
This works. All right, so can I get started? Okay, maybe actually before I start, it'd be kind of nice to do a round of the room so I know who I'm speaking to. Also, it helps me to understand what the level is that I should be speaking at. I'll do my intro maybe right at the end. You want to start off?
Sure. Yeah, my name is Sydney, and I'm one of the founders of NewSpace in OC.
Okay, awesome.
I'm Daniel Peters, and I'm interested in looking for investment for new development.
Okay.
And that's a long-term goal, and I'm here to see if I can help bring that long-term goal into a more present future.
Awesome. I guess you have a lot to talk to your neighbor.
Yes, my name is Luigi. I know most people here. I'm working on CubeSat. We're called Ragnarok. That's the name of the team. And that's for this NASA challenge.
Thanks.
My name is Nikolai. More recently, I've been trying to get into market analytics or consulting for new space companies. And then I also work for Earth to Orbit and Amrish Kolparta. I do client relations for
I think we're streaming online. This person here is business partner. She runs Flipper Dumpling. It's a dumpling shop, and she's interested in space food. This person here has a bow shop and a new type of pivot that she's working on. What's the new pivot? Your new business?
Space Compute.
Space Compute. Space Compute. I'm Sean Reed from Alpha Labs, and also founded NewSpace. And I love space projects and have been running a makerspace for the past 6 years and have a lot of different businesses that I'm working on as well. And I'm here to support the NewSpace group. This person here is creating toys for space, and that's his business.
Awesome. Lots of space entrepreneurship going on.
Yes. Very prolific person, Mr.
Hi, I'm Sadia, and I know most people here. I study biochem and physics in school, so I've always been interested in astronomy.
Okay, awesome.
Mike, and web development and space entrepreneur, part of NewSpace, and a couple other startups.
Awesome. Okay, well, thanks for that. It gives me a little bit of feeling of what talking to. So I'll, this is kind of informal, so interrupt or whatever. I'm going to try and keep it somewhat brief, and then we can have a general discussion about things. I'll give you a little bit of an idea of who I am and a couple of people who are working with me on this project, this very recent project, and what the project is about. But there's more things that we can potentially talk about. So we just founded a company called Space Junkies. Story behind that as well, maybe something for later. And we're based out of the Netherlands, and that's where I grew up. I'm actually currently living in Milan. I've been working for the last couple of years for a small space company on a variety of things related to space debris. So yeah, that's a little bit what I've been doing recently. I'll tell you a little bit more on the next slide about myself. And so what we're actually building is this platform / website / tool called satsearch. So what I'm here to talk about is something that I think is quite relevant to NewSpace. Depends on what you define NewSpace as. In fact, that's one of the collaborative exercises I've planned for one of the later slides. But the way I understand it, part of it is increasing this transparency within the space industry that's been lacking for various reasons for a number of, since the start of the space age. So this is part of us trying to help the industry move towards a more transparent process. Yeah, so that's. So my name is Karthik. I'm an aerospace engineer by training. So I'm currently working at a company called Dinamica in Milan, but actually my contract is ending at the end of next month. So I'm now rounding off a few things. I'm also in the final stages of wrapping up my PhD in aerospace engineering. and that's in Delft University of Technology in the Netherlands. That's where I did my bachelor's and my master's as well. So I'm hopefully, and I don't want to make any predictions because in PhDs it's impossible to tell, but I'm hoping to be able to more or less round off things, the bulk of it, by the end of this year.
What's your thesis on the PhD?
So I work on planetary ring dynamics, actually. So my background is in orbital mechanics. That's kind of where my whole passion for space ended up. And so I took that and transferred it to the world of astronomy and planetary science. And so I'm studying a specific ring around Uranus, which is kind of perplexing for a variety of reasons. And so essentially I'm a software developer, but building other stuff. So I've been building software for years now, but it's just scientific software as opposed to web software or consumer software. So one of the things that I did right after I finished my master's, so I did my master's in Delft as well. I spent some of the time in Milan, that's how I ended up there now. And I wrote my code in MATLAB, so closed proprietary system, got some results, wrote up my thesis, and that piece of code lives on a CD in my advisor's cupboard and will never see the light of day again. So when I started my PhD, I decided that's not going to happen again, because that is the single biggest waste of human effort I think that exists. So I decided right from the start of my PhD, whatever happens, even if it's not me that capitalizes on the fact that the work has been done, it should be out there. So I went around, talked to a few advisors, and they were not really happy for me to do this during my PhD because they wanted me to publish, but I kind of figured, look, this is my time to explore and build stuff as well. So I built this library called TUDET, the TU-Delft Astrodynamics Toolbox, and it's on GitHub. I can give you the link later, or you can grab it from the slide deck. And the philosophy behind it was very much the opposite of what a lot of end-to-end tools in the space industry provide, Satellite Toolkit and a few other software packages. The idea with this was really to have a set of rudimentary building blocks. So it's more for semi-experts than it is for novice users to just click and things to run. It's more about, okay, I want to build complex systems and I kind of want to understand how it works, and I need enough adaptability in the software that I can kind of dig straight to the core. So it's essentially a physics engine with a lot of access to the low-level blocks so you can build stuff. So I led at any given time up to 15 students in the group who were working on this. I kind of managed to onboard most of the supervisors in the group to get their students to graduate and write code in this. So it's been running now for 5 years, and there's a fair amount of code behind it. And I would say in excess of 30 students have graduated using and contributing to the tool. So that's kind of where my open spirit started, and it's persisted since then, and probably in some respects just taken off as well. One of the other things, just to kind of canvas some of the things I've done, so I'm also involved in the Austrian Space Forum. I'm not sure if any of you are familiar with the Austrian Space Forum. So it's kind of like the Planetary Society. They chose very early on to start focusing on Mars exploration. So what they've been doing, they've completed 11 of these missions, they've done these analog missions where they kind of park somewhere, and they have the whole suite of processes, what happens on Earth, what happens in the field on Mars, etc., and they run basically a simulation for this. So I got involved in this as an analog astronaut, so I got to walk around last August in a spacesuit on a glacier in the Alps, which is kind of fun. And the interesting thing is there's a lot of software involved in that as well. Communication software in the suit, and software that just provides life support, for instance. And a lot of this stuff as well has lived for a very long time in closed circles. And I think that there is sort of a movement towards open sourcing it, not just for the benefit of more people to get involved, but also to make the code more robust and kind of benefit from the many eyes idea.
How long did the mission last?
So we were there for 2 weeks. The longest that they've done, the longest campaign was in the Sahara Desert for a month. And they try to do one mission every 12 to 18 months. Not really sure what, because I'm not part of sort of the management of the group, what they're working on right now. But the idea is they're kind of building up these campaigns to slowly progress the technology so we can understand kind of where the bottlenecks are and where investment has to go. Mm-hmm. And so I worked also for a while actually out in California. So I did part of my PhD in Berkeley, and I worked at NASA Ames as well as a mission analyst for a bit. So I have a little bit of a feeling of how things work on this side of the water, not as much as I do on the other side, but it's intrigued me enough to understand that it's worth exploring things here as well. And interestingly enough, NASA Ames has sort of been the brainchild of NASA open sourcing a lot of stuff and doing stuff low cost. And I mean, they gave kind of birth to Planet Labs and a lot of these other new spacey initiatives that are hitting the market. So I think that it's an interesting place to be as well, because there's this thought process that I think is there. One of the things I'm interested to find out is if that thought process is here as well in the city and on the East Coast in general. But it's just to give you a feeling of kind of where I come from and what the philosophy is sort of I've been working on towards over the last few years. So I'm working with Alberto. Alberto is a software engineer. He's done a lot of different things. He graduated from his PhD in bioengineering and then was just fed up with it and went and became an iOS developer. So he's been working doing iOS apps for a while, and he's kind of migrated now. He works at a dev house doing back-end, front-end apps, the whole spectrum of activities. And we've known each other for around 10 years now. And I'd always thought, I just want to do a project with you. We're kind of buddies. And so this was the perfect chance for us to leverage that and to spend some time together, but also work on something that we feel is relevant. We have an intern who's actually working with us in India, Nishil. He's working on various things, data population in our platform, analytics, and some business development as well. He's a mechanical engineer and is into radio, amateur radio stuff. And interestingly enough, India is quite an interesting market for NewSpace as well. There's a lot of activity going on there. There's some way in which the market's also restructuring. The government policies are changing. That's making it interesting to consider side by side with all the other sort of traditional markets for space innovation. So that's just to give you a little brief outline of who we are. And this is an interesting question, and I thought I'd just leave it as a blank slide because I'm interested to hear what all of you think as well. NewSpace is sort of a term that's bandied about a lot now, but my understanding is everyone's kind of interpreting it in their own way. And some people consider it, I think, a philosophy. Some people consider it a series of applications. Some people consider it, a form of business entrepreneurship. And I don't really know what it is or if there is a strict definition. So I thought I'd kind of ask all of you, maybe we can do sort of a roundtable, what NewSpace is. I mean, a few people here founded something called NewSpace, so you clearly have an idea or some forming idea of what NewSpace stands for.
Well, before we do that, we're really limited on time, and your time is extremely valuable to us in the sense that we don't know about you.
Okay.
I'd rather
do this
possibly could really at the end if we have time, because I really would like to hear your business.
If you'd like to do that, we can skip back to this later. All right. So whatever NewSpace is, there are lots of charts out there like this. This is a popular one taken from SpaceWorks, which does market analysis and stuff. And they published this report in 2014, kind of showing this semi-hockey stick graph for small satellites. Of course, there's a lot of projection involved in this, and a lot of the concerns are whether this future market that's being projected is actually going to come to fruition or not, and what are some of the obstacles in that. So part of what we're working on hinges on some of the assumptions in this as well, that I have to say clearly. But I think there's a deeper sense that even if this doesn't happen, there are some low-hanging fruit to solve market inefficiencies, essentially. But yeah, that's kind of the backdrop to this. So if everyone's kind of on board with this, then I can continue with the rest of the talk. And if not, we can discuss this later, whether the graph is even relevant. So what is the problem that we're tackling? And this comes from a problem that I've had myself, working on preliminary mission design, developing mission concepts, is that there really is no easy way to search for parts. And I'm speaking about this in terms of trying to get a handle on, okay, I flowed down certain requirements, either I have a client or government as a customer, or I have some application in mind. And somehow now I have to figure out, okay, what I have in mind, is it out there or not? And is somebody working on this stuff? And if not, do I have to do the R&D myself? And that matching process is one that's time consuming. At least in my experience, it's cost me hours and hours of Googling. And so it was that limited scope of I don't want to do this anymore. Like I went to school to do a lot of other things other than sitting all day Googling. So I went to my friend and just said, hey, can we at least solve my problem, right? I don't want to be spending my time Googling. There's a lot of other interesting things I could be working on. So we went to a startup weekend event last April in Germany with this idea. We had a couple of people working with us. And what we quickly discovered is that that idea resonates with a lot of engineers in the industry. So cool, we thought, okay, maybe this is something interesting to work on. What we also discovered from people there who are suppliers themselves or other people that I've talked to is that the market is also highly fragmented, especially in sort of this NewSpace arena. Just to give you an idea, there's a lot of companies in India that we've now discovered that are just completely unknown in the rest of the world. And that traditionally has worked because they've always all worked in the value chain of the Indian Space Research Organization and never had to think outside of that. But now that there is an opportunity to commercialize stuff, they're also kind of looking to say, look, there are new markets that we can explore. Apparently we can leave, our borders. Where do we want to go? And finally, what we've discovered from talking to a number of people, including the CubeSat team in Delft, is that when you make mistakes in procurement, it can lead to a lot of backlog, especially for the kinds of projects that are sort of being worked on in the NewSpace world, which is sort of rapid, fast, turnkey solutions, where there's no allowance really for slippage. The kind of allowance that you had maybe with large missions like Cassini, where you could say, a month here or there, this thing's going to take 10 years anyway to develop. Not that it's any better in that circumstance to have a slip, but in this case, it's just you don't have that margin. So that was kind of the backdrop to this problem, and I went to my friend and said, hey, is there something we can do about this? So the interesting thing we discovered is that, and this chart is one that's come out of one of these other studies that we've done of the industry, is that the parts industry itself is quite high value. There's a lot of transactional volume in parts. A lot of it is hidden because it's happening in government contracts or in military domain. But actually, for a few sectors in particular, telecom is a good example, weather is another one, there's a lot of value in the parts market itself. It's not, it's dwarfed by the total size of the market for space stuff, especially the downstream services that still dominates where most of the revenue comes from in the industry. But there is a sizable amount of activity going on in the parts market, as it were. So what is the opportunity that we really think we've identified? The industry is really becoming global in the sense that borders, for a lot of reasons, are disappearing. Talk to people here, for instance, who've managed to even get platforms ITAR-free. So there's this idea that borders no longer restrict who you can do business with. Of course, that's not entirely true in the space market yet, but if the market continues the way it does, then potentially there's going to be a lot of cross-border work that has to be done. It's high tech, which means that investment in this industry itself represents a good place to be. In fact, the ROI of the space industry typically is pretty high. So it's one of the better places to put your money long term, at least from the European perspective. I don't know how it sits here in the US. Of course, there was this talk about all kinds of new applications, whether it's Internet of Things, satellites enabling your car to talk to your refrigerator, to talk to something, the factory on the other side of the world, whether it's all of the stuff about Internet everywhere or the likes of SpaceX and OneWeb and various other constellations are aiming. There's a number of applications that are out there that are suggesting that there's sort of an order of magnitude change going on in the industry. There's also some level of standardization going on. So the CubeSat standard is an interesting case. You have your believers and you have your naysayers. So I think it's, you can't argue against the fact that it's having an impact on the industry. And it's having an impact on the commercialization of the industry as well. And that allows for a lot of other things to happen because you start looking at satellites as platforms as opposed to unique, bespoke products. And finally, what we've discovered is the fact that there's much more robust consumer electronics. The fact that your cell phone, PhoneSat was a good example of this. Any of you familiar here with PhoneSat?
Oh, you set up an iPhone or something, right? Yeah,
so this was a project that came out of NASA Ames when Pete Gordon was there, and essentially was that thought process of, this stuff is pretty robust. What if we just launch a phone? And it did pretty well. So the idea that you have to engineer stuff to the limit is perhaps changing now. There's arguments against that as well. There's certain applications in which you can't avoid doing it, but at least there's a much larger sourcing market that you can source from if you consider consumer electronics something that plays a role in the space industry. And I know at least one company that is solely building off of this, off of non-space hardware. So what is our value proposition? So there's lots of ways to term this, and in fact, this is a work in progress. One of the things that we have tried to think about is what is the low-hanging fruit that we can help solve. So the way we position this, and I put Alibaba here because it's sort of a well-known player for business-to-business kind of transactions. But the ultimate goal for us is to build structured data for the parts market. So instead of having to skim through lots and lots and lots of PDFs, the very low-hanging fruit that we want to solve is just to make it parametric so that you can sort and search and filter like you can do with most things, like you can do with your laptops or your phones or refrigerators nowadays. And there's no fundamental reason in my belief that that's not possible with parts. It's not to say that it's an easy problem to solve, as we were discovering, but it's at least one at which we think there is an added value in having this. The other thing we've discovered as well is that there are some databases out there with parts, but we've also discovered that not all of them are very independent. That means they're not run in a way in which you necessarily always know that what's being presented is what you want to see. And the other thing is that we've seen that a lot of people have told us that they've tried to do this stuff, even build up personal databases, but they almost always just fall into by the wayside because people aren't paid to maintain this stuff. Right? They're paid at NASA or ESA or commercial companies to engineer products, and for their own use cases, they have these little databases that just never get, to the level that they're built into a sustainable tool. So we figure that there's an important point here to be made that it's meant to be something that deserves the attention of a group of people. Okay, and then there's various other things that we can talk about in more detail if you're interested. The very ideas we have, automating the process of how you get quotations, and generally managing the supply chain for the space sector, including providing things like market analytics and various other things that can help suppliers understand, okay, where should their R&D money go, where are potential new markets for them to access. So this is just to give you a very brief outline of sort of what we're talking about. This is it, what we have right now. It's open already. It's very minimum viable product. You can go and just, at the moment, we have a simple login form, but that'll probably disappear sometime soon for various reasons. And there's two tools that we've built based off of the data that we've aggregated so far. So one is sort of a Google-like search. You can just go in and type whatever part you're looking for. Of course, that search still has to be iterated on and improved drastically. The other thing we've discovered is in the data that we have been aggregating, there was also subsets of data that were interesting. So we have a supplier listing, for instance, that has geolocation data. So I looked at it and said, hey, what can you do with geolocation data? Well, you're on a map. And this has actually garnered a lot of interest, surprisingly. I mean, this was kind of an afternoon of, let's build a nice visualization. But we've had a number of people tell us actually that they want certain things to be built into that tool. And this is just a way to give you an idea of the kinds of things we're thinking of. These are work in progress, and in fact, what the important thing is what's underlying all of this, because these might not be the final versions of the tools or various other things that we expose. So what are we doing at the moment? So we ran a pilot study at my university at the end of last year, where we, in a classroom environment, just had a number of students who were working on design exercises work off of the tool. So we got some very good feedback, what was working, what wasn't working. We're starting to have a discussion with some of the online courses that are being done for spacecraft design, to try and understand if we can just provide direct support to remote teams that are trying to develop CubeSat concepts or whatever they might be doing. We're in the process now of bringing a few suppliers on board directly. So what we've been doing so far is just passively populating the database with a lot of the stuff that's just publicly available. But to complete the cycle, we're in the process of working closely with a couple of suppliers to pinpoint exactly where our value add is in their sales, marketing process, etc. So this, I mean, normally, and this is something that I should just say, I'm very forthright to everything, right? Because of this open source mentality, and maybe naive, I just tell everything, might end up killing us. But at least I think it's much better. I don't have to worry about what did I tell whom, right? So one of the things we're hoping to do is close this contract with the European Space Agency soon. It's not set in stone, so it could fail the moment I say this, but that would allow us to at least access some of their ways of doing things, and hopefully buys us a bit of credibility in the market as well, as not being just these two random guys, but with a little bit of support in the from, let's say, the space infrastructure that there is. And we're this year at various conferences, so we'll hopefully be at in Mexico for the International Astronautical Congress, and we have a few other events that we're going to talk about this. So what is the grand vision behind all this? Because this is interesting, but what are we actually working with? This is essentially what I'm after. I think it's quite a divisive statement because not a lot of people agree that this is what should happen. But from my background, one of the best things that we can do to make this space, or give everyone the chance to step forward in the space industry, is open sourcing. And that open sourcing can come at all kinds of different levels, right? It can happen at the level at which you're engineering something and using open source design. It can come at the level at which we allow information to live freely. It can come at the level at which we just promote collaboration and have people work together. But fundamentally, I think there is a problem that we've, given the fact that the space industry has had this very defense sort of character for a long time, we're hopefully breaking out of that mindset and moving into a space that allows much more communication and, as a result, of course, open up many more applications, transformative applications. So we want to be part of that, and I see this parts library that we're building as part of that process. But it goes further than that, of course. There are certain thoughts that we have, and these are all work in progress. I mean, you take it for what it is. It might be the craziest idea in the world, or it might be something actually that has value to it. So one of the things I'm really interested in is this idea of marrying machine learning and AI with design, engineering design. And one of the most straightforward ways of thinking of that is, I mean, if you take all of the stuff that there is in the world, right? If we have this parts database and we have a mission archive, and there are people who have archives of all the missions that have flown, and you marry that with machine learning, for instance, the idea that you might be able to quickly iterate through ideas without having to design everything from first principle, or you can do that side by side with doing some first principles analysis, might allow for a much more rapid and efficient process for design. Now, the way to think of this in my mind right now, and it might be a very silly idea, and feedback would be great, is remember this irritating guy who lived in Microsoft Office? I'd pop up every once in a while and say, are you trying to? That in a maybe a less annoying form, living in your CAD system, living in your systems engineering sheet, living in various other tools that you might be working in, is kind of what I see as a way that, you know, it's not about removing the engineer from the loop, but rather building this sort of man-machine interface in the engineering design process.
I would just replace Mr. Clip with a Watson logo.
Watson.
Use Watson because everybody has positive.
Right. Okay, so that's a good suggestion. Maybe better connotations than Clippy.
There's more model.
And so some of the ways in which we're thinking of doing that is, for instance, releasing an API. So you can programmatically start doing stuff with the database that we're releasing. So you can start doing sensitivity analysis, right? If you have a design that relies on a certain manufacturer coming through with a product, but you want to have a backup plan. You identified another manufacturer, but you want to understand if you switch from A to B, how does that affect your design, your operations? Is there something you have to account for that you might not fully scope out? Those are the kinds of things that I hope, you know, releasing an API will enable, so that you can talk less in terms of like how much margin do I have on my system, and more in terms of, okay, look, this is plan A, plan B, plan C. And one of the things is, so having a systems engineering background, I mean, or done some systems engineering work, I realized that a lot of this stuff lives in spreadsheets. And so having things like, you know, parts database just pop up when you're filling out Excel and auto-populate parameters in your fields, and kind of easily being able to iterate through that. That's part of the first steps in, you know, marrying design with data. Yeah, as I said, this is work in progress, so this is definitely going to change, but it's at least the vision, you know, that I had lying in my bed and kind of thinking about this stuff. And what is the core of this? So what my vision is to accelerate the design to solution cycle. So not necessarily anymore talk in terms of, I don't know what the NASA plan is, but in Europe it's, or ESA, it's phase 0, phase A, phase B, phase C, these sort of siloed design phases in which stuff gets handed over. That's kind of improved with computer systems being involved, But we're talking here also about a completely new way of design in the sense that there are people who want to be able to do design and then an hour later have something on the test bench and run it with hardware in the loop in your simulator to find out, okay, is this idea feasible or not? And throw it out if it's not, and go to cycle through to the next idea. That requires, I think, an acceleration and a new way of thinking on how to do engineering design. One of the things that we can see potentially coming out of this is just reducing the way uncertainties are treated in the system. At the moment, you slap on 20% of uncertainty on everything. And if it's even more uncertain than that, you put 50% on it. And you hope at some point, the mass budget converges and the power converges and stuff, but it's all a bit of guesswork, actually, that's going on in that process. So hopefully this can kind of inform that process so it's done with a little bit more of a sense of, okay, I know what I'm doing. In the end, if we're able to partly or even automate the design process, hopefully that saves man hours, which can be put into more time-critical things like buying down the risk of your mission, working on new technologies, etc., which I think is the real thing that engineers should be doing. Sort of my philosophy of all of this is Googling isn't the bit that you get your best ROI on. And finally, the very interesting thing, and this is one of the reasons why I wanted to give the talk here, I touch base, is I know that New York is also a hotbed of maker activity. And I kind of see that there is, more and more of marrying of the minds between the small sat world and people doing high altitude ballooning and sounding rockets and people building stuff with Arduino and people, and I think those two worlds need to meet because there's a lot of cross-fertilization of ideas that I think we can benefit from. And things like 3D printing and various other technologies that are appearing, additive manufacturing in general, I think should be brought into the fold. And whether it's in terms of buzzwords like Industry 4.0 or whatever else, the idea that these worlds should coexist more than the space world being off in one corner, I think is something that we're quite excited about. So for us as a business, we've taken that one step further. We've kind of said, okay, look, there are other verticals in which B2B search is interesting, where there's new applications opening up. A couple of examples are the professional drone market. So this is not the consumer drone market, where you can go on Amazon and buy a drone for $100 or $200. There's going to be applications, whether it's this ambulance drone that was developed at my university or a few other examples in which there's a level of technology that's required that sets it apart from the consumer applications. And similarly, the robotics market is seeing, in that sense, a lot of innovation happening, and I think also a lot of entrepreneurship is going to come in that space. So this is my final slide. What are we looking for, and what am I kind of here for? One is we're looking just to kind of get more user feedback and validation. So people are working on small satellites, people are working on building stuff and need to search for stuff. It would be just great to know, are we talking any sense? If there's a complete rubbish because, it doesn't work, or this isn't a problem at all. Taking it one step further, we are also actually then looking for collaborators and partners because there's various activities that we're undertaking where we think that there's a mutual interest to do it not in sort of a traditional buyer-seller, but really as partners. We're running already. We've run one pilot study, and we've got hopefully a couple more lined up this year. And the more we can get, the better we can understand the process, and the more we can dig deeper into where the pain point really resides. Part of this, and that's kind of the open spirit of it, is that community will become an important point. So people who are just interested, engaged, and getting involved, I'm hoping we're going to take the steps soon to just open source a lot of stuff. So bringing people on board who just, think it's a great vision to go for and want to be involved in that process is something that I think we're interested to hear about. Okay, to survive, at the moment we're bootstrapping it. I'm moving back home after April. We're going to do everything to kind of go into almost suspended animation. But beyond that, I mean, yeah, potentially if there are people who are interested, especially, seed funding gives us a little bit of room to grow this faster. So it's not a necessary part of what we're doing because it's a software play and something kind of that you can do out of your bedroom in the beginning at least. But yeah, that's something that if there are any people, you have any connections that you could hear about, it would be great to hear about. And finally, yeah, just anybody who's interested to have a chat with us, to tell me I'm crazy, tell me it's fantastic, tell me something in between, would be good. So that's it from me. I hope this was somewhat engaging.
I think great presentation. Your vision is great. I think you need to scope it very, very tightly. And I would say I have an idea to do your exit plan. In other words, to get you the money to do the rest of the vision.
Okay.
Starting with your database. There's a company called DigiKey that does this sort of function, but for the engineering community, the radio community, the amplifier people who deal with electronics. They would buy your company after you got some sales going, and they would buy it at a high multiple because they can see the growth and it fits within their existing business model and increases their bottom line, makes their executives look great, and so that's why they want to buy you. So this would fund your vision. And I like the idea of the expert thing building on the database because that's how designers for the CubeSats that will never fly will need to go through and buy parts and do it as part of their studies, and your growth is much higher than the actual number of CubeSats that will actually fly. So another part of this is a Kickstarter part of it. In other words, if you can incorporate a Kickstarter function, because this is how the Indian community, the developer, the people who make these instruments, who make the little parts that go into the CubeSats, they can test the market through a Kickstarter function that will fund them if they have a good idea. And so who's going to give them the most focused feedback is people who are actually looking for the parts to solve their small sat problem.
Okay.
So if it had a Kickstarter community type function built into the DigiKey database where you are normally going, and then all of a sudden it's not in the database, but somebody is doing a Kickstarter for that part and it meets my timeline, hey, I might put some of my budget into that Kickstarter because I know I don't lose the money if it doesn't come through.
Right.
If there's not enough demand, the part, the device never comes into existence, I still keep looking.
I just want to hear from you. Like, how do you guys source parts?
We are very
just gave up on that actually earlier because the parts that we need have to be ran hardly, and so the parts that are sold by MySpace, by NewSpace,
$5,000 for a main board. It's crazy.
oh yeah, it is expensive, but that's just that computer, which is like a 40 megahertz computer. The one from NewSpace, that one was like $77,000. And it's using an FPGA that's like, it's like the Vertex core.
Well, this is one of the things that's interesting, and it's where we get people a little bit upset, is the market, people on the supply side of the market are benefiting from the lack of transparency.
Yes.
There's a lot of arbitrage going on, which makes our task difficult, right? If we had a cooperative environment, this would happen much faster. The point is, we've got to find a way to get the critical mass without a bunch of suppliers essentially killing us. We're trying to do that by picking the easiest go-to-market strategy. So we've got a few suppliers, essentially by going to the newer companies who don't have the market share, who have nothing to lose. We've discovered that there's an interesting play there. And for the existing suppliers who ignore that, I mean, it's either at their peril or they'll be proven right. But there's an interesting point in that, but there's also, and maybe that ties into what you're saying, parts that don't exist. Part of the function that we're considering is exactly that, because you might not be, if there's only one CubeSat that ever flies to the moon, okay, that's a different point. But if we imagine that that's the start of something that's going to happen more frequently, then potentially you're not the only people who are going to be looking for it.
Well, I can tell you right now, it doesn't have to go to the moon. It can be like
Or even
obviously
geo.
science missions. Right. Yeah. That's where the market is. If you just show the plot that you have all of these services that make up almost like 70% of what is being invested in, right? All this money. I think it was like $100 billion you have there. Right. So in geo, you have satellite TV, radio, telecom. And then if you do NEO, you have all of the nav, right? And then obviously LEO is just flooded. But with LEO, you can throw parts. You can throw your cell phone in space if it's in LEO.
Exactly.
But if it's if it's going to be in NEO or if it's going to be in GEO, that's not going to last. It just won't.
Exactly. So that's why I find it interesting that you haven't found anything, because I don't think you're the only person that's identifying that issue, which means that there's potentially there's a lot of future market things to this that are difficult to drill down now. When somebody asks me, what's the size of this market? I mean, right now it's not impressive. There's not a lot of stuff going on. But if you believe in these kinds of things, right, small geo and all these other initiatives where we're pushing some of these technologies further than the traditional low Earth orbit, okay, then you start thinking about maybe there's something going on. Yeah.
I mean, there's like a lot of things that we could talk about. Like for instance, if you like software, I'm sure you can focus on like, so for instance, Linux is open source, but you have different packages that you can sell, right? So like I was telling you earlier, CFE is the name of this open source flight software that is from NASA Goddard. So we're going to use that, but there isn't enough material for us to base it off of. They have these guidelines that's not very good, and it's not very clear. There aren't enough examples online to show you how to do this, because he uses, it is a real-time operating system, and kind of your own PC has apps that will run and you can shut down. It's the same exact thing. It's nothing similar to like running like one of those 40 megahertz computers where it's like a really big switch case, like that's like the top level, and then you have different modes that you run through. If it gets stuck in the mode, then you have to reset it. You can't just get out of it and it's finished.
Task manager and this.
Yeah, you can't just do that. It's finished. So
one of the interesting ideas that we're thinking about, working towards, talking to some people about, is exactly that part of how, is there a way to bring design and the engineering design closer to real-time stuff, right? So if your onboard computer is running your OS and you want to test certain failure modes, that's part of where it falls into all the work I've done to build this, for instance, this astronomics open source library. This is actually part of what I imagine as an asset pipeline. Right? So parts library, simulator, orbit simulator, link budget simulator, and putting all of those in a way in which you can put your onboard computer that you have on a rack and have it go through more, cycle through the entire mission. Whether that'll happen or not in reality is, of course, time will only tell, but that's part of where this vision comes from. And the parts library is simply, I realized from my own work that it's a pain. And that's why we're starting with this, hoping that, of course, it brings us to a bigger vision. I think somebody has their hand up for me. How many what? Sorry?
Parts.
How many parts do we have in the database? Good question. Good question. Very good question. So actually, we don't have a whole lot, and that's kind of where we're trying to understand what's the best way to fill the database with parts. So we have about 300 parts in there now across a few different categories. What we don't want to do, so you could potentially think we hire 1,000 people, and they call up every single supplier, and they sit there and type to the computer. But that requires a lot of money because you have to pay a lot of people. So what we're trying to figure out is, can we solve the problem another way? Can we figure it out in a way in which the data wants to come to us? And the way we're trying to do that is by telling suppliers, look, if you give us the data, there's a lot of stuff that we can contribute back to you. That's an ongoing discussion to understand, do suppliers want to give us that data? How do we negotiate them? What do we have to give them? But yeah, that's what we're doing. Do you have any ideas?
Building on a question, if Luigi's looking for momentum wheels, could he go to your, I envision that he would go.
yeah, I saw the site. It had the wheels.
Okay.
You can type, the search is not perfect, so if you type, we don't have the regex working perfectly, and it doesn't all do concatenation and stuff, but the basic principle is. And at the moment, we've just got data sheets there, and we've taken out mass as an experiment, and the idea is to structure that data so you can really do parametric search.
Can you purchase the parts from the site? Or do you go?
I should be careful what I say here. So no, you cannot purchase the parts from the site. The reason I have to be careful is that's the one thing that I think will kill us today. Because suppliers are very sensitive about us getting in the middle of their deals. Yeah, it'll happen, I think, right? I'm predicting this to the world, that it'll happen, but it won't happen overnight because
We can put a very large list price.
already exists. CubeSat shop.
yeah, there are certain things that I won't necessarily talk about just because I don't want to piss off certain people. There's a reason why we're calling it search right now, because the feedback we've gotten is, if you want to survive, do that instead of calling yourself an e-commerce site. It's also, there's many more dimensions to selling stuff that we don't need to solve right now. Even just having the search available is solving a problem. At the very least, I spend less time doing Googling. So potentially, yes. If you have any ideas on how to get to that path, or if you think that that path is worth it, then interesting.
Do you keep metrics on the searches? So can you tell like a certain part is like more popular than another one? Yeah.
Yeah, that's and then again, I'm very careful. Data is all anonymized, so we're not tracking people or anything. But I have like graphs that I can even show, where we have most interestingly, one of the things we're doing because our search is so incomplete at the moment is if you type something in and it doesn't result in a search, we track it. So then I can filter and say, okay, look, what are people searching for that we just don't have? So we discovered through that S-band receivers, for instance, are very popular. We received a lot of searches. Part of the searches went wrong because of the way the search functionality worked, but a lot of it was because we were missing parts. So we're trying to organically grow the database by using those metrics to say, okay, these are the things that people are actually looking for.
CB, how can you utilize that information to increase the company value? Is there some way we could offer that as a service?
I was going to say approach NewSpace Global and say we know what people are looking for when they're building satellites.
Right.
And here's how many people are looking for that.
Well, but the vendors, the people who are designers, they can design an S-band or they can design L-band receiver. They could use that information to make an important decision for them as to what Kickstarter they might want to offer people who are looking at S-band.
Well, I'll give you an example, a concrete example, which is kind of the validation that we got. There was a paper published by somebody at the European Space Agency in partnership with Goddard, and that's kind of how our partnership started with them, on an analysis that they did of GNC parts. This guy had just kind of started curating it in a Google sheet. He got a few of his buddies to join, somebody from Goddard as well. And they had a few hundred products in there, hand curated, and this guy knew the industry, so he kind of knew who was telling what, whether it's right or not.
Who was it from Goddard, from GNC?
That I don't know. I know the European side of the equation.
That was the part, yeah, that was good.
Greenbaum, I think. Greenbaum, that's the last name. Greenbaum. I can send you the paper. It's out there in the public domain. So the interesting thing is they had these products and they started doing just some statistical analysis, like, plotting histograms of, for instance, some property of reaction wheels and then just by frequency in the database. In that particular case, they found something very special because they took the parameter momentum storage, which is a measure of the mass, inertia of the wheel, and they plotted a histogram. And so the database was incomplete, so they knew already they were going to be missing part of the histogram. The data was kind of noisy, but then there was one band in which there was nothing there.
That's an opportunity.
So they wanted to know, is this an artifact of the data? Did we somehow bias, in our sampling? But it was kind of odd because they statistically calculated the chance was really small that we wouldn't even get one product in that bin if the product existed. And what they discovered after doing some research was the part really didn't exist. So then the question became, okay, does the part not exist because there's no application of it? But what they actually discovered happened was a lot of customers who have specs start searching passively. And they realize that the part doesn't exist. And then they compromise in their design and say, maybe we should take one that's a little bit less momentum storage, a little bit more. That means the vendors never understood that there was a need in the market for this. And on the back of that, there were 2 suppliers at least now who are producing parts in that gap. So that's sort of where we think, on the supply side, there's some way in which we can add value that we can kind of finance ourselves through this process of aggregating that kind of data. So, I mean, that's part of how we live long enough.
I think it's the shortest horizon minimum viable product, and I think focusing on that database, I know it doesn't meet your entire big vision, but I think it's the best way for you to get up the next step.
That's what we sort of figured out. Just trying to understand if
and it's a growth. What else we can do because there's so many people that do this thing. Everybody knows it's the next big thing. It's the next plastics. It's the next microcomputers. So all these different college courses. They're all going to be building these sats, and they're not going to go anywhere. But they're going to be building sats, and they need parts, and they need your database.
That's how we're set up.
I need your database.
That's awesome.
Yeah, I always envy the guy.
Well, you can go in and already play around with it, and feedback would be
It's
great.
not complete enough. I mean, I really want this DGP, I want this parameterized searching. I want to be able to.
But that's what we want to know, exactly what you want, because that means we can build what you want instead of guessing. So,
But it's simple. These are VC persons. Everyone's directly related. Each has the cash in his pocket. What do you do?
Yeah, I was too wondering what kind of partnership you're looking for in order to build momentum for your.
So supplier partnerships are very important. And in partner, I say partnership because that's what it has to be. That's be a win-win situation. We're trying to work on that. So anybody who has leads to specific suppliers who are maybe more of this mold of thinking as well. The market's changing. That would be great. And then really start embedding it in teams. And one thing at a time, kind of figuring out how we solve problems. So just having a link to like the CubeSat team in Delft, where I'm trying to sit next to them and do this. The more we can do that, the deeper we can go into the process and understand, okay, where are we adding value and where are we basically wrong in our assumptions.
So some of us were at the small set conference last year. Were you there?
In Utah now.
So it was pretty interesting. We have an idea of the whole ecosystem. I wonder if they go to all the suppliers there, do you think that they would actually talk to them?
I think if we pitch it in the right way, if we pitch it in a non-threatening way, we're not here